Hey Titans, we're going to stick with radical operations here, but the last operation we're going to talk about is division. So if we see a problem like this where we have 16 divided by 25 all underneath a radical, what we can do first is let's rewrite it as two separate radicals. So the top radical is the square root of 16 divided by the square root of 25. We can rewrite it like that. Now if we look at this, we know the square root of 16. The square root of 16 is 4. Right? 4 times 4 is 16. We also know the square root of 25. Square root of 25 is 5. So our answer there is 4/5. Okay, if we look at this top right example, it's already split up for us. Now, we don't know what the square root of 5 is, and we also don't know what the square root of 45 is. Those are going to be decimals. But what we can look and see is if they're both under a radical, what we can do is we can look to simplify this fraction. So if we think of 5 and 45, we can simplify that down. 5 and 45 simplifies to 1 over 9, right? Because 5 goes into 5 or 1 time, and 5 goes into 45 9 times. Now if we look at this, square root of 1, remember that means what times what is 1? Well, we know 1 times 1 is 1. Square root of 9, what times what is 9? Well, 3 times 3 is 9. So we have 1/3 there, and that's simplified. Okay, now let's try that again. Let's look at the bottom one. We don't know the square root of 8. We don't know the square root of 50. But I think we can simplify that fraction. And since they're both under radicals, we can look to simplify it. So if we have 8 over 50, 8 doesn't go into 50. But we know 2 does, right? So 2 goes into 8 4 times. So on top, we're going to be left with the square root of 4, which is good. We know what the square root of 4 is. 2 goes into 50 25 times, which is also good because we know the square root of 25. So if we do square root of 4, that's 2. Square root of 25, that's 5. And that fraction is simplified. Okay? Now, notice all three of those answers that we just had, there were no radicals in the denominator. And remember, the denominator is the bottom of the fraction. Okay, a rule that we have with radicals is we cannot have a radical in the bottom of the fraction, in the denominator. Okay, so let's do an example. Let's do, what if we have something like 2 over the square root of 3? Okay, now this is pretty simplified, right? There's not much else we can do. We can't simplify 2 and 3. The 3's in the radical, the 2's not. We can't really simplify that fraction at all. But we can't leave the square root in the denominator. Okay, so what we're going to do is something called rationalizing the denominator. Okay, and what that means is we're going to find a way to get that square root of 3 out of the bottom of the fraction. Okay, what we're going to do is we need to multiply, and we don't want to change the value of this fraction. We just want to somehow get that square root out of the bottom. So we can always multiply something by 1, and it doesn't change the value of it. Like, for example, if we had 4, 4 times 1 is still 4, right? It didn't change the value of it. So that's what we're going to try to do to rationalize this denominator. Now, we don't want to just multiply by 1, because if we do that, we still get 2 over square root of 3 in the end. Okay, but if we can think of a fraction to make 1, okay, so what we want to try to do is we want to multiply by the same thing on the top and the bottom. Because think about this, if we did 3 over 3, 3 over 3 simplifies down to 1. We want the same number on top and on bottom so we don't change the value of that number. So what we're going to do is we're going to take whatever radical is in the bottom and we're going to multiply by that number on top and on bottom, in the numerator and the denominator. Okay, now watch what happens. The top, 2 times the square root of 3, be careful, they're not both radicals, so we can't multiply the 2 and the 3 together. What we need to do is we're just going to write them right next to each other. It's just 2 square root of 3. Be careful there. Don't make that square root of 6, okay, because that one's not underneath the radical. Now the bottom, we're going to use the rule that we learned in the last video. If we have the square root of 3 times the square root of 3, remember, same radical, and we multiply them, the radicals cancel out. So square root of 3 times the square root of 3 is just 3. Right? The long way was square root of 3 times square root of 3 is the square root of 9. But we know the square root of 9 is 3. This is the same answer, is the same value as this. It's just with our radical out of the denominator. Okay? Let's try another one here. let's say we have 5 over the square root of 2. Okay, simplified, right? 5 over 2, we can't simplify that because that's not underneath the radical, but it's illegal because we have a square root in the bottom. So we're going to multiply, same thing on top and bottom, and we're going to multiply by this square root. So square root of 2 and square root of 2. Because remember that, if we divided those, it's 1, and we multiply by 1, it doesn't change the value. We're gonna rationalize this. We're going to get that out of the bottom. Okay, the top, they're not both under radicals, so we can't multiply them. We just leave it as 5 radical 2. The bottom, square root of 2 times square root of 2 is 2. Right? It's really the square root of 4, but 2 times 2 is 4. Okay, that's our simplified radical there. All right. Let's do, I got one written down here let's do 6 over the square root of 2. Okay, now be careful. We can't simplify this. Even though this looks like 6 over 2 is 3, since that's outside of a radical, that's just a whole number there, we can't simplify with the number underneath the radical. So we need to rationalize it because we can't keep that in the bottom. So we're going to multiply, remember, by whatever's in the denominator. So square root of 2, square root of 2. Okay, top. Remember, don't multiply these together. We're just going to smush them together. All right, 6 square root of 2. Can't multiply them because they're not both under the radical. Square root of 2 times square root of 2 is 2. All right, we're going to get good at this little shortcut here. Technically square root of 4, but square root of 4 is 2. Now look at this. Don't leave this. This can be simplified. Okay, now we can't simplify radicals and non-radicals, but we have 2 whole numbers here. Okay, we know that 6 over 2 is 3. Right, so actually our answer is 3 times the square root of 2. Okay, technically over 1, but we don't need the 1 in the denominator. Okay, so that's working with rationalizing denominators. Thanks for watching.